We'll see.
All right, does anybody have any questions about the homework before we keep going? Y'all should. No? Yes?
I mean, you couldn't do like half of it, seems to be the general consensus.
All right, why don't we go right for the jugular and do the last one, it was the hardest, and then I'm gonna show you a trick that solves the problem, all right? So first, here's the deal. This is the last one in a nutshell. All right? This was 5 microseconds, 10 microseconds, and so forth. The level here is 5 volts. And we'll call this x of t. It doesn't matter what the function's called. So that's the actual waveform. And you want to take that waveform and turn it into an infinite series. We're going to use an exponential series. We're not going to do the cosine series. I'm just going to do the exponential. We can turn that right into the cosine series. So we know that x of t is equal to a summation here from n equals minus infinity to infinity. And do yourself a favor, put n unequal to 0 of x of n times e to the j n omega naught t plus x0. Now the reason I broke out x0 by itself, it's just the average value. Do you all follow me on this, class? So all the other ones are going to be included in the sum except for n equals 0. Now what is x0? Well, it's 1 over the period, the integral from 0 to t of x of t dt, correct, class?
Mm-hmm.
It's just the average value. You take one look at that, you don't need to do an integration. You can see the average value is 2.5. That's a right triangle, right? We could integrate it if you want to, right, class? We could go ahead and say, if I wanted that, first I need an equation for that line. An equation for that line, since it has a 0 intercept there, is just what? X of t is equal to the rise over the run, that's the slope. So what's that? That's 5 microseconds goes up to, and this is, it's 5 over 5 microseconds, or 10 to the minus, or 10 to the 6th. So it's 10 to the 6th t, right? And this is valid for t greater than 0, less than 5 microseconds. Do you agree with that? Remember, we just have to do, x0 is this, we just have to integrate it over a period. So you can leave it as 1 over t, the integral from 0 to t of simply 10 to the 6th t dt, and you can get 10 to the 6th, right, over capital T, and then it's going to be t squared, evaluate over 2, divide from 0 to t, which is going to be, that's going to be t squared over 2 from 0 to t, and that means x0 will be equal to 10 to the 6th times t divided by 2, and since t is 5 microseconds, so it's 2.5, and that's how you would do it if you wanted to integrate it. Does everybody follow me on that? x0 is just the average value of the function. Does everybody? Now, you can just eyeball that. You don't have to show the integration. Everybody got that much? All right, next part is, how do we get the value of these x of n's? Well, x of n is what? It's equal to 1 over t, the integral, and you can go from 0 to t if you want, but it has to be over a period. So you can go from minus t over 2 to t over 2. You can go from 0 to t, right? Over a period. You have to go over the length of a period for this one, because you're going to be weighting it by 1 over t outside. Now you put in the value of the function. The value of the function is 10 to the 6th t. Why don't I make this function x of t just k times t, where k is 10 to the 6th. That way I won't have to keep on writing 10 to the 6th. So I come over here and I put it in here. This is k times t times e to the minus j n omega naught t dt. Do you all agree with that? Right? You follow me on this one? I took the function, I multiplied by e to the minus j n omega naught t dt. That's what we covered in class. Is everybody with me on this? How many see this right? All right, now make sure you keep up with this homework, because if you don't, you're going to get clobbered right here. It gets really complicated in about another 2 lectures. You have to be on top of this stuff, or you're going to be left in the dust. I cannot, some people won't believe it, but I'm doing my best to encourage you to don't play games with this. This is not history. All right? You can't cram this one. You will get killed. You will flunk. I promise you. A lot of people flunk this course. So now, when I have that right there, what do I need to do? I'm gonna take the K out in front so I can make you focus on this right here. Now this is an integration by parts. I don't like these. I have to deal with them, but I don't like them. So the way you usually do it is whenever you see this exponential times something, let that be du. So du is equal to, by the way, when I say integration by parts, what I mean, for everybody's record, when you take a differential of u times v, that's the product, right? It equals u dv minus v du. Do you all follow me in this class? Now, the idea is, if I have u dv over here, then that would be equal to the differential of uv, and then it's going to be, plus, minus v du is equal to u dv. And then when we integrate this and this and this just goes down to uv, and you evaluate the limits. This you go do the integration of, and you get the integration of the thing you wanted. All right, the thing I've got is this. So my du, I'm going to make e to the minus jn omega naught t dt. Bear with me a second, I'm trying to get a darker color. That was brand new. It's not gonna... How many remember integration by parts? And I'm going to tell you, everything you learn in your mathematics courses, you have to have a very good feel for and knowledge of, because engineering is math-based. Everything we do is immersed in mathematics. Some of the more complicated math we'll explain to you later because you haven't had it. But you have to be very, very good and skilled in that. So make sure you brush up on anything you need to. Now, how many got to this point where that's the differential du, right? Then what is v going to be? V is going to be t, right? Now you go ahead and you complete what you need. So this means when I integrate to get u, I have to integrate that. I have to basically integrate e to the minus jn omega naught t dt, and that means u becomes simply 1 over minus jn omega naught times e to the minus jn omega naught t. Does everybody follow me on this class? A simple integral, right? And what is, and when I take, to get dt, what happens, or dv, what happens? dv becomes simply dt, correct class? Everybody with me? So now I go ahead, that's the original thing, now I do the integration by parts, and I say it's equal to k divided by t, and now I put up, first I had v du, so I take u dv, so that's going to be 1 over minus j n omega naught, right here, times e to the minus j n omega naught, right? T, and then it's dt, right? And then I have that minus, what is it? Yeah, it's just the, this is, what I'm trying to say here is, this is, right here is going to be u dv, correct class? That's u dv, and that has a minus sign, a minus sense to it right there, so I'll put that there. And then it's going to be, that has a minus plus, and then it's the differential of what I actually want, which is u times v, so it's t times t divided by minus j and omega naught right there, e to the minus j and omega naught t. And yeah, that's a differential, that's a differential. Do y'all follow me, class? That's dt, this is d of this whole thing. Are you with me, class? How many remember doing integration by parts? You remember that? You had to do that all the time. The normal form you saw was this. It was x e to the ax, and you had to do this dx, an integral. And you let that be equal to dv or du, and that be equal to u. Do you all remember that? That was, yeah.
Shouldn't the second term just be t times the exponential function?
Well, the thing is, when we integrate this, the differential goes away. See, this is the differential of this whole thing. I haven't put the integral sign on yet.
Oh, okay.
All right, now you put the integral, all right. I want to make sure you see this, and remember that k over t stays out in front, right? Now when I do the integral, what happens? Well, I still have k over t here. The minus signs cancel. When I integrate this again, now I have 1 over minus quantity jn omega naught squared downstairs, and then I have e to the minus jn omega naught t evaluated from, and this has to be evaluated from 0 to t. I'm going to leave it like that. Then when I take this integral, I just have minus t divided by jn omega naught times e to the minus jn omega naught t, and I evaluate that between 0 and t. Now you'll notice the only thing I'm doing, when I do this integral, I get another jn omega naught downstairs with a negative sign, right? I do this integral, I just bring out this, because it was a complete differential. Are you with me? Like when you do the integral, if you have the differential xu, and you integrate that, that just gives you xu. Everybody follow me on that? Then you evaluate at the limits. Now what happens to this one when you evaluate at the limits? If you take a look at this, take a look at what happens. Now omega naught is equal to 2 pi over t. Do you all agree with that? Now let's take a look at this one first, this part. I'm going to actually put it over here, I want you to see that I'm going to do it right here. When I take a look, I have k over t, and don't worry about t right now. Now I look at the first part, this one. Now just watch this. I have 1 over, put that down here, I have minus jn omega naught squared there. Just leave that alone. Now I have to evaluate this. So what happens when it's 0 here? That's just 1, isn't it, class? Up here, what do I get? I'll put the minus 1 here. I get e to the minus j, and omega naught is now 2 pi over t, right? Times t. Do you all see that, class? That's this portion right here. When I'm evaluating a t, I put a t in there, capital T. Omega naught is 2 pi over t, so the capital T's cancel, the periods, and I have n times that. Now this gets interesting. I want you to pay attention to this. Forget n for a while. You all see how t goes away. I want you to listen to this. This is important. First, what is e to the 0 equal to? 1. What is e to the j 2 pi equal to? Go all the way around, you're back to where you started, right? 1. What is e to the j 4 pi equal to? 1. What is e to the j 2 pi times n equal to for any integer value? Class? 1. What is 1 minus 1? 0. That's the point I was trying to make. You all with me, class? So that first one goes away. You'll learn to see these things. Anytime you see e to the j 2 pi n, it's 1. It doesn't matter what n is. It can be 0, 1, 2, 3, 4. Go on, you can follow me? As long as it's in it. So that goes away. What about the second part here? All right. Now you'll notice when it's 0, t is 0, correct? So we don't worry about the bottom term. We don't worry about the subtraction. The only thing that survives is t. So now here for this one, I'm talking about this. Please just bear with me. I don't have enough board to do justice to this, but when I take a look at this, I'm going to have k over t. That's out in front. And then when I evaluate this here, that's capital T. Now follow me on that. That's minus capital T, correct? It's divided by jn, omega naught here, and then it's times e to the minus jn 2 pi over t, because that's omega naught, times t. And now we're going to have this discussion again that I just had with you. Does everybody see what I'm doing here? And this is, by the way, that is your x of n, the coefficient. Can you follow me on this one? I'm sorry I had to work a little fast because this problem takes a while to build, right? There's a lot of little things you have to worry about. Now, when we're down here, I want you to just pay attention. What is this value going to be? First, take the t out, yeah, capital T. That is 1, so get rid of it. It's irritating. Now, when you look here, what do you get? Well, you all see how the capital T's go away, right? Omega is 2 pi over t, so you put a 2 pi down here and a capital T here. Now k is what? 10 to the 6, isn't it? You remember that? But what is t? 5 times 10 to the minus 6, correct, class? So t times 10 to the 6 is just 5, isn't it, class? So this is 5. And that's the constant. That's how you do it by integration by parts. How many hate integration by parts? Me too. So I'm going to show you why you don't have to do it. All right? I wanted to make sure. We can do all of them this way. All right? They're all simple problems. There's nothing complicated. But they're nerve-wracking, or they're irritating, because there's so many little steps. By the way, did anybody get that? And here's how you prove it, too. You can go ahead and use this constant, and then you can put it in terms of not the exponential series, but you remember I did something on the board, and I'm going to just erase this whole thing. I want to put it here for you, and I want to underscore this, because if some of you didn't do your homework, you're really cutting your throat on this stuff. It's really suicide not to do it here. I don't say that lightly. I mean, I know enough about students that I know there's always the good students, no matter what I give them to do, they will try their best shot at. And then there's the intermediates that kind of take a look at, and then there's some that just don't care. And these don't care people flunk this course because it's the first really challenging course, in my opinion, that we have. So now when I take a look at this, do you remember how I made that into x0 plus a summation where it's single-sided, 1 to infinity, of x of, now it's going to be twice times the magnitude of x of n, times cosine of n omega naught t plus the phase angle of x of n. Do you all remember that? How many do? That's a cosine series. The reason I do that, this is a singly infinite series. All right? Much easier to plot than a double, or to create than a doubly infinite, in my opinion. And also, it's taking the magnitude of x of n and the phase angle. So you don't have to worry about a lot of weird, complicated math up there. Now, you can take this and you can use, how many use MATLAB here? How many use Python? How many use Mathematica? How many use MathCAD? I like MathCAD myself, that's my favorite. Or you can take this and you can plot it. You can literally say, I will create x of n here. And you know, I just gave you the formula for that. What was it? It was minus 5 over j times 2 pi n, wasn't it? Wasn't that it? All right, so you can go ahead and in MATLAB, if you're doing, I think MATLAB is what I'm supposed to use for this course when I give you things like this. In MATLAB, how many know MATLAB? How many have used MATLAB? Let me go with that. Have you used MATLAB or not? I'm curious, or not?
Yeah,
Kind of, sort of?
Yeah.
What class, though? I need to know what class.
I couldn't see.
I mean, how many, is there anything where they make you use MATLAB? Circuits
Circuits
does?
a little bit.
All right, well, I'm going to tell you one thing, because I sense a lot of bitterness about MATLAB, just talking to students. This is the thing you have to realize. In the real world, when you guys are trying to make money, the first language that people prototype means the very first time they create a piece of software, they use a higher level language. MATLAB is used almost all the time, except when Python will do the job. Python is just like MATLAB, but there's a little more complication. But the reason they use Python, it's free. And it doesn't require any kind of formatting. So you can pull in huge amounts of data. And you can do data mining and stuff like this, and you can do it without any kind of problem or payment, underscore payment. Companies don't like spending money on anything they don't need to, especially a few of my friends' companies that are small. They would rather use it free. That's why they use Python, and I'm just learning. Who knows Python in here? One, kind of, sort of, kind of, sort of, kind of, sort of. You know Python?
Yeah.
Well, then you can do this quickly in Python. Because what you have to do is first, in MATLAB, I can tell you how to do it. In Python, you help me. What you would do in MATLAB is you open an M file. This is an M file or a script. They call it script. And what you'll do up here in the beginning is clear all. I want people to do this. Then you put close all. Now there's probably one command that does this whole thing. So clear all, close all, and then CLC. That'll clear the page in the main window. You have your main window is where the information comes up when you ask it for answers, right? or you have equations equal, boom, comes out there. After you do that, and this is CLC, now you can populate it. You can say let n go from, I don't know, 1 to capital M, and up here make m equal to like 100, right? So now you've got a vector, integer values from 1 to 100. 1, 2, 3, 4, 5. Follow me on this? Now after that, and you don't have to do it this way, there's other ways. After that, now you create this stuff right here. You say x of n is equal to -5, and I'm going to tell you this, put a dot there. Anybody ever know what I'm talking about? Because MATLAB does matrix division. If you don't, now when it does a dot, it's scalar division. I'll speak more on that later. Make sure you put a dot there. And then the division symbol, quantity, J is just, I think it's I in MATLAB, but it could be whatever J is, times 2 times pi times n. Now you've created those. Next thing what you want to do is you actually want to plot this thing. So now you need, so come from here over to here. Now you put a for loop. For, it can be I equals 1 to say, let's do this. Before I put this there, this is the way I do this. I need two things. I need something indexed in n where I sum all the terms, I mean the C of n's, right? And I have to do one other thing. I have to do something where I index time, right? Because time is going to be what I'm going to plot it against, right? I'm going to plot this thing right there over one period or 2 periods. So what you do is this, and write this down. You're going to have t in MATLAB. What I'm going to do is, I'm going to let I be, better yet, this is what I'm going to do. T equals, and it's lin space. So it's linear spacing points. And the points go from 0 to the period t. And put something up here, the period t is 5 microseconds. You're going to have to put that in a separate place. And if you know MATLAB, you know one thing you hate to see is every time you don't put a semicolon after these things, they just pop up forever. You follow me on this? So put a semicolon after everything you don't want to see. This is sort of a MATLAB for dummies, as fast as I can throw it, what you need to know and why you need to know it. So put semicolons on all this stuff, or you're going to see it over and over and over again. Now what I'm doing is I'm linear spacing points from 0 to t, and now you tell them how many points. And you can just put a variable in there. You can put like L. And then somewhere up here, you're going to have L equals maybe 1,000. So you're going to create 1,000 points. You're going to have 1,000 bits of information that go from 0 to t. It's spacing t here. Are you with me? Now, to get this function, you've got x naught. You've calculated that, right? This is the function you want to get. So you need a for loop. So I is going to be the index on your for loop, and it's going to go from 0, it's going to go at 1, use 1, to the value 1,000, because there's 1,000 points there. Or just put 1 to L. Now, the next thing you do is you say x of I. And what this is doing is going to store the value for each increment in time. You know, you have a period and you broke it down to 1,000 little pieces, right? So in the first increment, when it moves from 0, this is the value you're going to get. And x of I is going to be equal to, and now you have to use the sum command. And you're going to sum, and it's going to tell you on what index to sum. How many of you used the sum command before? All right, it's going to sum what? Well, it's going to sum this term, and actually, let me do this. I'm going to break this out right here. I'm going to say first, I'm going to create something. I'm going to call this, for lack of a better term, G of I and N. Now, what I'm going to do in there is put down, it's going to sum C of N, all right, times e to the j n times omega naught times t of I. Remember, t is indexed on I, right? There's 1,000 points there. Now you're going to have to do one other thing to be careful. This multiplication in MATLAB is an asterisk there. All right, are you with me? So what I've done is I've created these terms. But now I have to sum these terms. from 1 to some value. Now you can't sum to infinity. So you sum to some finite value. In this case, 1,000. Right? Because that's the number of time spots, right? Or excuse me, not 1,000. You solve to the number of terms, which was n. So n goes from, n is 100, so just put m here. And it doesn't start at 0, it starts at 1, right there. So now I put down, then I can put down my x right here, and it will not be of n, it will be of I, is equal to the sum of this term, g of I dot n. So I'm taking this term, putting in here, and the number has to do with what you sum over. If you put 1, it's going to sum downward the columns. See, what we've got here is this. For this term right here, that g of in, what it looks like is this. These are going to be the indexes. This is going to be 1, 1, 1, 2, 1, 3. Downward is going to be equal to 2, 1, 2, 3, 1. Are you with me on this, class? Now these indices are what these indices are in the array, all right? Well, you want to sum over the n value, so it would be 2. Down, I believe down is 1, 2 is over. Does anybody, can you correct me on that? Sometimes I have to look it up. That's the way they sum. You can just look on Google or just type help sum on MATLAB in the window and it'll show you. Now when you do that, it gets x of I. What it's doing is finding the value of your function that is going to model that x of t, the original one, at incremental values of I. And I have to do with t, right? And then once you're done with that, you're just going to sum it there. Then you have to put an in statement. So now you have a for loop with an in statement. I'm doing this for a reason. I'm going to ask you to do something with this. This is just, I'm not just blowing steam. I'm doing this because I'm going to require something of you that I'll give you credit for. This goes beyond the call of duty, but it'll help you. Now you have to do a plot. All right? So then you plot, and you can look up how to label plots. All this stuff is self-explanatory. If you just go to Google or YouTube, how to plot a MATLAB, there's so many people that readily make it available to you. And I thank God for Google, well, not Google, but for YouTube, I'll tell you that, because YouTube really helps. But all these browsers, they make learning trivial. I mean, how fast can you learn? Well, as fast as you can type, basically. So you're going to plot. And what are you going to plot? First thing is the horizontal axis. So you're going to plot t right there, and you don't even have to put of I. It's already indexed in I. Just put t if that's what you're using as a symbol, and then x. Because this x now, right here, is already indexed on I. And then it'll plot something like this, you know, it'll give you that. But what you're going to see is you're going to get, you have to actually do one other thing. I didn't show you this. When it comes out of here, plot x, and you need to add plus x naught there because that's the average value. And I didn't include it right there. Do you follow me in this class? So it's x plus x naught. And then what you're going to see is something that closely approximates that. Now right here, right at this corner here, once you do it, I'll talk more about it, you're going to get a discontinuity. You're always going to get overshoot. It doesn't matter if you have a billion terms, you're still going to get overshoot there. And I think it's 8% overshoot. And the reason you get that is something called a phenomenon, it's called the Gibbs phenomenon. And it means when you do Fourier series analysis and you have a discontinuity, something that goes instantaneously from one value to another, that's a discontinuity. What you're actually going to get is an overshoot, and it'll like ring like this in a very short length of time. So you will never be able to capture that exactly with Fourier series analysis unless you do something to get rid of it. And that's a little more advanced, but there's ways of doing that, okay? Now, you all wrote that down. I'm going to ask you to do something with this for Friday for me that you're going to hand in. And I know some of you are going to work together. It's probably, for this case, it's probably beneficial to learn how to do this stuff. Now, that said, you all see what we did there? And once you plot that, you'll see it works. By God, but I'm going to show you yet a better way. A way that you'll love. And you'll thank me for it because it's not in a book. And this is sort of my gift to you, because when I teach EMC and radar, I will not, if at all possible, ever do an integration by parts. Mathematicians find beauty in that. I don't. That's work. It's not, and some of these things, the long ones especially, you have to do integration by part 2 and 3 times. Irritate the meter, no way. All right. So now, a better way. Call it that. We're going to start with a function. Any function at all. I'm going to pick one that looks like this. It's periodic. It looks like a triangle. Did you have to do this one, by the way? I think you did, didn't you? Didn't I give you that one? All right, now that one is an integration by parts twice, which makes life so much more fun, right? You have to do it twice to get the coefficients, don't you? Let's just call this t and be done with it. Let's call the amplitude a. All right, that's the function. This is my x of t. And I want to take x of t and I want to turn it into an infinite series. If I'm talking fast, it's because I see that clock looking at me and I know how much time I have to cover this. I'm going to slow down when it gets important. You all understand what I'm talking about. It's a function. Now I know that x of t here is equal to, we're going to just stick with the exponential series. Whenever you plot it with, you know something? I had the exponential series in there. Do the cosine series, because I didn't exempt. I had just positive values. I didn't have negative values. Put down in your notes, use cosine series, and I'll send you a little packet of information to help you, okay? What you replace it with. All right, so this one, n equals minus infinity to infinity. Here, it's going to be some x of n times e to the j n omega naught t. Now we got to make sure we know what all the parts are. We first have to get the period, right? Well, that period's given, so you just have to have eyes and look, whatever that number is. After you get the period, now you get f naught. That's the fundamental frequency is 1 over t. And I think everybody knows the relationship between period and frequency, right? All right. So this is the fundamental frequency. After that, you get omega naught. And that's 2 pi over t, correct, class? That's the fundamental, that's the key. Now after that, I need to get x of n, right? Now the fun begins. This and this are exactly the same. I want you to watch what I do next. But I'm going to erase this because I need this part of the board. What I'm going to do is this. On this side, I'm going to take a derivative, x prime of t. Please watch this. When I take a derivative of that, what does it do with respect to time? The prime means with respect to time. It's the slope of that line, isn't it? Well, that's t over 2. So the slope would be rises a divided by t over 2. This would be 2a over t, and it would be that slope until I hit this point right here. And then at t over 2 would go down and be minus 2a over t. And it would be a square wave. Do you all agree with that? Take a careful look. Do you all follow me? It's just the derivative, right? Derivative is the slope. It's rise over run. If the rise is negative, then it's negative. If it's positive, it's positive. What happens over here? That's a derivative with respect to time. So now x prime of t is equal to a summation, still of n equals minus infinity to infinity. I'm supposed to put n unequal to 0, but don't worry about that right now. All right, from n minus infinity to infinity, but when I take a derivative with respect to time, what happens? Take a derivative of this with respect to time, what happens?
Pull out
The
constants.
j n omega naught, right. So now I get x of n, the original x of n, times j n omega naught times e to the j n omega naught t. Do you all see that? Right? It's another infinite series, but this time it has a j n omega naught in front of it. Does everybody see that? Now this, do you all agree that this is just a constant, correct, class? So if it is a constant, then I'll call this constant x prime of n. Please watch this. That means when n goes from minus infinity to infinity of x prime of n times e to the j n omega naught t, Do y'all see that that is a Fourier series? It's a constant times e to the j n omega naught t, correct, class? Now, how do we always get the constants? Well, we say that x of n prime is just equal to 1 over t times the integral of x of n prime, or x of t, x prime of t, times e to the j n omega naught t from 0 to t, or over any period, dt. Do y'all agree with me there? And now I'm calculating the value of x of n prime, but if I wanted x of n, I'd just divide it by j n omega naught. Do y'all see this? I want you to notice what I'm saying. I'm after x of n, right? But if I have that, x of n prime, I just need to divide it by j n omega naught, don't I, class? We're about to the point where the miracle happens. Take another derivative of this, and what do you see happening? Well, what is a derivative of u of t? Isn't this really like a u of t function? What's the derivative of u of t? Delta, right? Now, here we get spikes. Now you see it went from minus 2a over t here to plus 2a over t. So now you get a spike here that has a height of 4a over t, and it's a delta function, and it triggers at 0. You all see that? How many see that right there, right? Take a derivative of a square wave. It's got to be deltas, right? Because you go from something, you take there's a discontinuity. It goes from 0 to some height, right? Instantly, that's a delta function. Do you follow me? It's a derivative of u of t. Here, it goes down. It's negative, minus 4a over t. Where does that occur? It's delta. This would be, you don't even have to put it here, but this is at t over 2. And you could write it as delta of t minus t over 2. And then finally, when you hit this corner, it goes back up again, and the whole thing repeats itself. Do you all see that, class? I want you to take a good, solid look at that. This was my original function. The first derivative is this. This is the second derivative. This is x double prime of t. How many see this now? Guys, I want you to make real sure you see this. I've included some information in the supplemental I've got on OneNote that is going to describe this. Now, why are delta functions interesting? First of all, do you all agree now that the double prime series here is equal to what? Well, it's the summation from n equals minus infinity to infinity of what? Take a derivative with respect to t, what happens? Don't I get j and omega naught out in front again? Sure. So now it's going to be x of n times j n omega naught squared times e to the j n omega naught t. Do you all follow me on that? Instead of having just j n omega naught, now it's j n omega naught squared. And in fact, this becomes x n double prime. That is the coefficient for the second derivative of the original series. And it's still in the form of a Fourier series. So now that equals n equals minus infinity to infinity of x of n double prime e to the plus j n omega naught t. This is in the form of a Fourier series. And therefore, we can get x of n double prime. And we can say x of n double prime is 1 over t, the integral from 0 to t, of x of n x of double prime, the second derivative with respect to t, of x, times e to the minus j n omega naught t dt. I know I put a lot down there. Write that down. And I need to tell you why that's so important. Because what is this x double prime of t really? It's a bunch of delta functions, isn't it, class? Delta functions are very nice things when you've got integrations. Because what do we know? If you have an integral from minus infinity to infinity of a delta function of t times anything, doesn't matter if it's an exponential or not, of t, make it not just t, make it t minus tau dt. What happens there? What do you get if you have a delta function multiplying something and you're doing an integration over the region where the delta function triggers? What happens?
You get f of r.
Wherever it turns on, right? In this case, t equals tau, right? It extracts the value of the function next to it at that time. So this is simply f of tau, isn't it, class? Are you with me? All right, now let's look here. Now let me kind of wrap it up here so you see it. This is going to be a couple of delta functions, and I'm going to get there. Do you all follow me? The only thing we're going to do is take this value, e to the minus jn omega naught, and replace t with the point that the delta functions turn on. Follow me? Then, once we have that, that's x of n double prime. How do we get x of n? We divide by jn omega naught squared. And now we have x of n without ever doing the painful integration by parts. Just by doing a couple of physically realizable, very easy to see derivatives. Got me on this, guys? Now, there's more to this, but I'm gonna wrap this up. So now, what I can say with the one I had, right here, I've got delta functions, and I want you to listen carefully. When you take the derivative, the final derivative where you just get spikes, you have to look and see, well, where does it repeat itself? I know it repeats it from here to here, right? That's the period. But you see the delta function's turning on there. Don't ever start at a delta function or stop at a delta function. Move your window of integration from here to here. Move it just below. That would be a period. And you'll notice something else. Up, down, up, down, up, down. You need to capture two of these sequentially in order to get the right integration for x double prime of n. So what happens here? Well, this integral becomes 1 over t. And let me bring it up here. My x of n double prime becomes 1 over t. I normally don't even put this down, and I'm going to go from, like, say, just below, call it minus epsilon to t minus epsilon. What I'm doing is shifting that window of integration down just a shade, okay? Epsilon's going to be a very small number. Now what do I have in here? Well, I have something that's got a height of 4a over t, right? That's the weight on that delta function. The first one's positive, it triggers at 0. The second one's negative, and it triggers at t over 2, right? When I say trigger, it means it turns on. Are you with me, everybody? And then it's times e to the minus jn omega naught t dt. Can everybody follow me here? I'm going to get, hey, wait, I have 5 minutes. I'm so used to ending a quarter to. Are you with me on this? Now, what happens to this? What is this? Well, I want you to think about this. This is x of n double prime. Where does this one turn on at? T equals 0. Do you all see this? If it's 0, I evaluate e to the minus jn omega naught times 0, or its e to the 0 is 1. So now I can say I have 4a over t squared. The first one, when I integrate it, is just 1. What about the second one? There's a negative sense to it. When does this turn on? T over 2. So now I have e to the minus jn omega naught t over 2. And what is that? That's x of n double prime, right? Can you all follow me? But that's not what we want. What do we want?
X of n.
We want x of n. What do we have to do to get it?
Divided by j omega.
By jn omega naught squared. You all see this, class? How many see this? Not one time. It's jn omega naught squared. So take this and divide by 1 over quantity jn omega naught squared. And that's equal to x of n just by itself. Now, that's what you're looking for. You'll notice I didn't do one integration by parts. I didn't have to pull my hair out. The only thing I had to do was take a couple of derivatives so I got delta functions. Once I got delta function, game over. Now I'm just evaluating e to the j minus j and omega naught t at where the delta functions turn on. That's it. I'll show you a few other things that are tricks. You'll notice that when I have this omega naught t over 2, omega naught times t over 2, well, omega naught is 2 pi over t times t over 2 is just pi. Do you all see that? So you can replace the omega naught t over 2 by pi. Another thing you can see is right here. What is j squared, anyone? Negative 1. So you can get rid of this, and you can just put a negative here for now. Or you can switch the order. Now I have n squared omega naught squared. I'm going to break n squared out by itself. But what is omega naught? It's 2 pi over t, right, squared. You notice the t's go away, right? Now I have 2 pi squared divided into 4a. Well, 2 squared is 4. You get rid of the 4 also. You see it? There's a pi squared left. For this one, do you remember how I turned the thing into a sinc waveform? How many remember that sinc waveform thing? You can turn this into a sinc waveform. I'm not going to do it right here, but you all see what I'm doing. Now this makes that stuff simple. We're going to do a problem. Pick a problem that I gave you. We did this, we brute forced that one. I can do that one again, but there's one other thing too. If you don't have all delta functions after you take a derivative, you get a couple of delta functions, then you have to call the delta function series like x1 prime or x1 double prime, right? There's going to be a function x1. The ones that didn't go to deltas yet, you take another derivative on there, and you would call that like x2 triple prime or whatever. Follow me on this, class? So you can break it up like that. And I don't have time to do that problem, but I got 3 minutes, and I'm going to do one problem. Which one would you like? Find one that's got variation. Well, we can do, just show me one you want. You got the homework? Come on. Ruth, Lydia, any of you guys?
I don't have it with me.
Rick, any of them? Which problem would you like? Which one didn't you get? You said you didn't know how to do any. Which one?
I didn't know how to do 3, but I don't have it on me.
You got the homework,
I
anybody?
don't have it on me, I'm sorry.
Do y'all remember? Oh, come on. All right, we did this one, right? All right, now they become trivial. What if I had this one? All right, I'm gonna show you. This is gonna be the no-brainer. This one we did, I think we did this one. Let's say this is just A, this is T over 2, this is T, this is X of T. I don't want to do this is versus time. I want a Fourier series where I have X of T equal to a summation of X of N e to the J N omega naught T plus X0 N equals minus infinity to infinity, but N unequal to 0. You don't have to write all that, just listen. In other words, I want that series. What am I going to do to this to make life easy? Class. Derivative with respect to time, right? So right here I get a delta function. I have a delta of t. You don't have to put the delta of t, just show the arrow. What about here? Minus a, delta of t minus t over 2, correct? What about here? Goes back up, right? Back down. Does everybody see that? That is my x double prime, or x prime of t, is equal to the summation here of j n omega naught times x of n times e to the j n omega naught t. And the sum is from n equals minus infinity to infinity, right? And now this becomes my x of n double prime. And I can say my x of n double prime is 1 over t, the integral, and it's over a period, of that right there, which is now a times quantity delta of t minus delta of t minus t over 2 times e to the minus j n omega naught t dt. Just tell me what that equals quickly. I have a over t coming out in front. All right, do the first one. What does this become? 1. All right, what does this become? Minus
J and e to the negative j.
e to the minus j and omega naught times t over 2. You all see what I'm doing here, class? Now, what do I need to do to get x of n? Guys?
Divide by.
Very good. Divide this by j and omega naught, and I got another class coming in. Thank you. You'll
So-
thank me for that.
That shouldn't be, is it supposed to be a double prime?
No, it's
First
Is it just
prime.
one?
Just
Okay,
one
all
prime. My
right, all
bad.
right.
I'm trying to fly. Really fly. Because every time these kids are looking at me out there. All right.
So do we have a MATLAB assignment for this?
You're going to get one.
Okay, will it be posted on the OneNote?
You better believe it.
Okay,
You
all
would
right,
know
sweet.
about it unless I'm going to put an assignment up there for Friday, and there will be a quiz on Fourier series
I'm not
analysis.
quite sure yet.